welcome back. This is Mrs. Atkinson, and today we are going to be starting lesson 11-1 called Reading Line Plots. You're going to need to take out your math workbook and open up to page 591 for our guided notes today. We're going to be doing part of this lesson today and the other part tomorrow. Let's start with our solve and share. Emily went fishing. She plotted the lengths of 12 fish caught on the line plot shown below. What was the length of the longest fish caught? And what was the length of the shortest fish caught? And we can solve this problem whatever way we want. So, the first thing I wonder is, well, how many fish did Emily catch? If I count these little dots, each of these dots represents one fish. So, if I count how many there are in total, there are 12. And it said that in the problem as well. Another thing that I noticed is that she's measuring the fish, and this line plot here is showing the length of all the fish that she caught in inches. So they want to know the longest and the shortest. So to find the longest fish, I would look all the way to the right, and the dot the furthest to the right is at 8 2/4. So 8 2/4 would be the longest fish. And to find the length of the shortest fish she caught, I would look to find the dot all the way to farthest to the left, and I would get 6 1/4. So this would be my answer. Let's take a look at the very bottom of the page, right? So how does a line plot help us see relationships in data? And it's actually very simple. A line plot is just a way to make it easier for us to read information. And it makes it easy for us to read at a glance. And so you should have that written down on your paper. You can pause the video if you want. If I'm moving too fast, you can always do that. All right, let's turn this paper over. You can either have it ripped out of your math workbook, or perhaps you don't want to rip it out, you want to keep it in. Either way, it's fine. So a line plot shows data along a number line, just like we've been talking about. Each dot above a point, and sometimes it's not a dot, sometimes it's an X. Each dot above a point on the number line represents one number in the data set. An outlier is any number in the data set that is very different from the rest of the numbers. And a common question that kind of comes up sometimes is, will all sets of data have outliers? And the answer to that is no, not necessarily. And can there be more than one outlier? And yes, there can be. If there's maybe like one all the way to the right set apart and one all the way to the left set apart, they would both be considered outliers. Let's talk about this guy, Eli. It says the table below shows the distance Eli walked his dog each day for 7 days. How would a line plot help you identify any outliers in the data? All right, well, let me get a sense of what this data is all about. Before I even think about a line plot, I just want to look at it and just really get it in my head. So it's the distance walked. He mentioned a dog walking. So I guess on Sunday he walked 1 mile. Monday he walked a half a mile, so like a little bit less. Tuesday was a big day, 1.5 miles. Must have felt good that day. Wednesday was another 1 mile walk. Thursday was 1.5. Oh, kind of like Tuesday. Friday, oh my goodness. On Friday, he walked 3 miles. I bet the sun was shining. It must have been a beautiful day that day. And Saturday, another mile. All right, so I noticed some are the same. Some are higher, some are lower. Okay. So the first thing I want to do is read the line plot. And I noticed that when I put this data on the line plot, right, one dot is at the half. That 1 mile mark, I have 3 dots because it was Sunday, Wednesday, and Saturday. For 1.5 miles, there was 2 that were a 1.5, right, Tuesday and Thursday. Nothing for 2, nothing for 2.5, and then 3 miles on Friday. So just looking at this data table, we can tell a few things. The most dots are above the number 1. So the most common distance was about 1 mile. The shortest distance was that half mile, and the longest distance that they walked with the dog, Eli and his dog, was 3 miles. Okay. Now I want to see, were there any outliers in this data set? Well, I noticed that the dot above the 3 is far away from all of the other dots, making it pretty different. It kind of stands out. And so the 3 miles would be the outlier right there. This guy would be your outlier. All right. Here's a fun thing to do. It says put 4 dots on the line plot below. So 3 is not an outlier. And how did I decide to do that? Where to place your dots? So take a minute, pause the video, and you go ahead and try that. Put 4 dots anywhere you want to make that poor number 3 not be an outlier anymore. So if I was going to do it, I don't know, maybe I'll put 1 here, maybe I'll put 2 here, and maybe 1 more here. So that shows that he's not all the way to the side by himself anymore. Now, your dots didn't have to be exactly where I put them. You could have put them different places. You could put, some by the 3 and some by the 2, but you can see now how they're more spread out. So it's no longer very different from the rest of the other distances. Okay. Let's take a look now at page 593. I'm going to look up at the top. I'm going to write it down for you. This is the next page, 593. Okay. We're going to jump right into this next line plot. It's all about giraffes and how their height, I guess how tall they are. So the first thing that I want to do before I even jump to the questions is get a sense of my line plot, right? Try not to jump right to the questions. I know it's hard to do that, but you really want to kind of just see what they're talking about first. So heights of giraffe, I have 2 giraffes that are 14 feet tall, I guess, 15 feet tall. I have 3 giraffes. So like 15 is the most common height. These 2, the rest are at a tie, right? There's none of them that are 17. All right. And how many giraffes did we, look at in all? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now let's take a look at the questions. How many giraffes are 14 feet tall? Easy. We look over here at the 14. We see 2 dots. So our answer is 2, right? Or 2 giraffes, really. What is the most common height? Well, let's see. The most common height for the giraffes is 15 feet because there are 3 giraffes that are 15 feet. Okay. How tall is the tallest giraffe? Well, the tallest giraffe would be 18 feet tall, right? And there's actually 2 of them, 18 feet. And is 18 feet an outlier? And explain. Like, is that an outlier? And the answer really is, it is a little bit separated. Like, we have that 17 in between. But the answer to that is no. 18 feet is kind of, it's not really that far off from 14, 15, and 16. So our answer is no. And if we want to rate a reason, we could say 18 feet is similar to the other heights. Right, 18 feet is not that far from 16, so it is really not an outlier. All right, now it's time for your independent practice. If we were in school, you'd be doing this on your own. So I really highly suggest that you pause the video right now or mute me and answer these questions and then kind of fast forward or check back to see what the answers were and to see if you were right or not. So we're going to use this line plot at the right to answer these questions. And again, most important step is to look at the actual line plot before you start answering the questions. Just get a sense of it. So they're talking about times for 100-meter sprint. So I guess all these are probably people, these dots, and they did this 100-meter sprint, and this is how long it took them. So there was one guy who took 10 seconds, 10 and 1/10 of a second to do that sprint. Wow, that's pretty good. This guy over here, all the way to the right, he took 11 seconds. Now, I feel bad for him because he lost, right? Obviously. But like he didn't, like he's not that far off from all the other people. All right, well, now let's answer some questions. So, how many people ran the 100-meter sprint? Well, to count the number of people, I would just simply count the dots. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So, my answer would be 20 people. Okay, which time was the most common? So which time has the most number of dots? And that would be 10 and 4/10 of a second, right? Or seconds. So 10 and 4/10 seconds is the most common. And which time is an outlier? Which time is a little bit separated from all of the other ones? Well, that would be this guy over here, 11 seconds. And now we have a question here. How many more people, oh, they love asking this, how many more people ran 100 meters in 10 and 6/10 seconds than in 10 and 1/10 seconds? So how many more signals to me subtraction? So I need to say, well, how many people did the 10 and 6/10? So that would be here. So it'd be 3 people did that. And then 10 and 1/10 was just one person, right? So 3 minus 1 would be 2. So your answer is 2 more people. And now question 11. Curtis said more than half the people ran 100 meters in less than 10 and 4/10 seconds. Do you agree? So here's 10 and 4/10, and he's saying half ran it in less. So is this going to be half of the people? 1, 2, 3, 4, 5, 6, 7, 8. And there was 20 people in all, right? So half of 20 would be 10. So I'm going to say no, I do not agree. No. Because 1/2 of 20 is 10. And only 8 people ran, sorry, I'm running out of room here, ran the race in less than 10 and 4/10 seconds. All right, so no, that is not correct. All right, we're going to just do one problem from the back and then we are all done. And you guys are going to go on to Pearson Realize and do the 11-1 homework buddy. Okay, let's see, which one do we want to do here? You know what, I think we'll actually do the top one. All right, time spent completing a project. It says Mr. Dixon recorded the times it took students in his class to complete a project. How much time was most often needed to complete the project? So, some students did it in 2.5 hours. One kid, it took him 3 hours. 2 kids, it took pretty long, 3.5 hours. So the most often needed time was, if you look up here, there's 4 dots. The most dots are above 2 and 2/4 of an hour. So I would say that was the most common, right? How many students are in Mr. Dixon's class? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 kiddos in Mr. Dixon's class. All right, and there could have been lots of other questions that they asked based on that line plot, but those are the ones that they asked, and we were able to interpret them. If they were to say, is there an outlier? I would say no, right? There's not any point that is kind of different or far away from the other ones, so I wouldn't say there's any outliers in that guy. All right, guys, this sums it up for this lesson today. You can get started on your Pearson 11-1 homework buddy, and I hope you have a wonderful day.